欢迎来到心灵机器世界。
Welcome to QUANTEC TV. Today we're going to be taking a closer look at the matter of which we and the things around us are made up. Get ready for a surprise. Matter is very different to how we perceive it. Let me demonstrate this using the example of the population of the world. As of 2015-2016, there were around 7.5 billion people on planet Earth. Let's assume an average weight of 65 kilos per human, and let's multiply that by 7.5 billion. That gives us a total weight of around 500 billion kilos. If we were to imagine these 500 billion kilos of humanity in the form of huge dice, we would naturally assume that that would be an enormous mountain of matter. But that's not how it is. Because of representations of atoms showing the electrons circling very closely around the nucleus, we think of atoms as being primarily made up of matter. In reality, the proportions are very different. The ratios of the nucleus to the distance at which the electrons orbit it is actually 1 to 100,000. Or, to put it another way, if the diameter of the nucleus was 1 millimeter, the electrons would circle around it at a distance of 100 meters, or at a distance of 1 kilometer if the diameter of the nucleus was 1 centimeter. If we now imagine a sphere of marble with a diameter of 1 kilometer, only the 1 centimeter nucleus and its electrons represent matter. So this nucleus and its electrons weigh just as much as the whole marble sphere with a diameter of 1 kilometer. The empty space between the 1 centimeter nucleus and the electrons which are orbiting at a distance of 1 kilometer does not weigh anything. It follows that more than 99.9% of the atom is not made up of matter. We can also conclude from that these nuclei are extremely heavy. They weigh 100 million tons per cubic centimeter. If you were to fill a die with 1 centimeter sides with nuclei alone, that means without the electrons that orbit the nuclei at the distance, then this 1 cubic centimeter die would weigh 100 billion kilos. Let's look at an example. Imagine that you were asked to pack as many hot air balloons as possible into a freight container. Inflated, you would not even get one in. But if you just load the baskets with the envelope folded, several hot air balloons would be able to fit into the container. The heavy nuclei have an even bigger outer part. Without these outer parts, a large number of nuclei could fit into a very small area. Now let's go back to look at our calculation of the weight of all humanity. We arrived at a figure of around 500 billion kilos. Since a die with 1 centimeter edges, as we have just seen, weighs 100 billion kilos, 5 dice represent the space needed for all the matter from which humanity is made up. In this picture we have 6 dice, so we have 1 die to spare. Right, now you can ask from where we got this figure of 100 billion kilos per cubic centimeter. We googled the density and weight of nuclei and searched the results for a reliable source. We eventually found what we were looking for on the website of the Max Planck Institute for Extraterrestrial Physics. When we scrolled down a little on their website, we eventually came across the relevant information. So if the whole of humanity can fit into 5 dice, it becomes clear that each of us only exists in the form of matter to an unimaginably small degree. After all, we have to share these 5 dice with the other 7.5 billion people. We find that this fact has to be borne in mind if you want to influence matter, regardless in what form. We have now arrived at the end of the first part of our Holodeck Earth series. In the next part, I will show you how the cells of an adult human would stretch around the Earth 60 times over if lined up one after the other. Thank you for watching.